In the last session, I was going to finalize on t-test, but I needed to elaborate a little bit more on this t-value formula. At the same time, I wanted to introduce the sortable bridge between t-test and ANOVA. That's why I'm going to spend a little bit more time on this. So, going back to t-value formula, it is the absolute value of the mean difference between the two subsamples divided by square root of standard deviation of the first subsample squared divided by number of cases in the first subsample plus standard deviation of second subsample squared divided by number of cases in the second subsample. What's really important here is this absolute value. It means it doesn't matter which one comes first. In the last session, I used male subsample as the first subsample, so 6 was the mean number of traffic tickets for male subsample minus female subsample's mean number of traffic tickets. So it was positive 4. That's why I kind of skipped this important part of the numerator. But it doesn't really matter which one comes first. So if you use female subsample as your first subsample and then subtract male subsample's mean number of traffic tickets, then it's going to produce negative 4. But since you're using absolute value, it's going to single out the plus and minus signs, so it's going to be 4. So what this indicates is it looks at the distance or difference between the two mean values, not necessarily which one is higher or lower. And you are using this distance and this standard deviation information or dispersion information to make a decision on null hypothesis. And what does null hypothesis say? It says that there's no difference between male and female subsamples in terms of the continuous variable. So your rejection or acception of null hypothesis is all about the difference or distance. So your alternative hypothesis is that simply that there is a difference between the two subsamples, not necessarily which one is higher or lower. And only when you reject the null hypothesis and accept the alternative hypothesis, then you can go on to compare the two subsamples' central tendency. So in our case, in the previous session, male subsample's central tendency was higher than female subsample's central tendency in terms of continuous variable. That's why you concluded that males were more likely than females to receive traffic tickets. And now, let me introduce a different angle on this frequency distribution. This is frequency distribution of number of traffic tickets for male and female subsamples, or first subsample and second subsample. And as was the case in a previous session, the mean values for each subsample are the same. So these are second subsample's mean. So you already know that these overlaps are the ones that's going to make you having a hard time making a decision on null hypothesis, because the larger these overlaps are, the tougher for you to reject the null hypothesis. And this overlap comes from this dispersion, because again, across these scenarios, the means are the same. So compare this dispersion to this dispersion here. And you see that how large it is compared to this one. And because this one is large and this dispersion is large compared to this one, there's this much of an overlap, and this is so it all comes down to the dispersion. Now try to look at it from this angle. if possible, and consider these centers as central tendency measures, which is mean. So I use these dotted lines because I want to indicate that these means are the same and these means are the same, just like the cases here. So this is just, again, just a different angle on this frequency distribution, and this dispersion determines the size of the circle. So this dispersion corresponds to these dispersions, probably the average of these dispersions for each subsample. So basically these dispersions are small, so that's why you have this small circle. And here in the second subsample for this first scenario, the dispersions are relatively small, that's why you have this small circle. And because of that, there's no overlap between the two subsamples. There's no overlap between the two subsamples. Compare this to your second scenario. In the first subsample, now the dispersion has gotten larger, and that's why you have a larger circle, larger than the first one in the first scenario. Look at this dispersion, how expanded it is. And that's why you have a large circle here. By contrast, your second subsample remained the same as it was in the first scenario. So this dispersion is just the same as these. So this is pretty much the same thing, this one and this one. That's why this circle remained the same. This is just as big as this one. So because of this expansion on the first subsample, in the second scenario, you see this overlap. And this overlap corresponds to this overlap here in the frequency distributions. Now, this one shouldn't be tough to understand. Now, look at this dispersion and compare this to the first subsample in the first scenario. It has gotten bigger and bigger. So, this is why we see this large circle. Probably this dispersion is pretty much the same as this dispersion in the second scenario. That's why this circle is just as big as this one. And how about this second subsample? Now its dispersion has gotten bigger as well, and that's why the circle here is a lot bigger than the first or second scenario. Now, accordingly, you are observing a larger overlap between the first and second subsamples. And this, of course, corresponds to this overlap in the frequency distributions. And again, this overlap indicates similarity between the two subsamples. And again, your null hypothesis would be like this. These two subsamples are pretty much the same. That's why you can consider this as just a one big one. Just one single large circle. And how different is this from this? That's going to be the decision making on your t-test. Now in the next session, I'm going to apply this point of view in analysis of variance.